Okay, largest number. Let's have a look. We're given an integer n, and we want to return the largest number that contains exactly n digits. Wow, okay. So first thing to notice, n could be anywhere from 1 to 7 in that inclusive range. So we're not going to have a 0-digit number. We're not going to have an 8-digit number, but it could be anything in between. Okay, so as you guys know, I usually like to start with kind of a naive interpretation. I like to start with kind of a brute force sort of thing, so if we can, right? So that's what we'll do here. We'll basically just take a look at, well, I guess there are a few ways we could do this, but I'm just going to make this like as simple as possible. So I'm going to do this. I'm going to say for let n be assigned the value of 1, and no condition on this loop. It's an unconditional loop. It's going to go forever. In fact, here, let's just make sure. Let's just say true. Just keep going. You know, just go for it. And that's kind of a dangerous thing. You might be looking at this and thinking, I think that's going to time out. And yeah, you know, if we were to run this, for sure, it would time out. It's never getting out of this loop. So there are basically two ways that we can make it get out of this loop. We could say, like, you know, if some condition, then break. Just stop the loop and get right out of it. As opposed to something like a continue, which would mean stop this iteration, but go on to the next one. You know, do your n++, check the condition, and then continue. Whereas break just says, okay, meet you outside, we're done here. Another way we could do this is under some condition, we could return something, you know? And the idea behind this is basically that the return is corresponding to our function largest number out here. So as soon as we see a return, that's not going to execute any longer. We're not going to have any more iterations of the loop. We're not going to have anything else from this function. It's returning its value. It stops there. So I think that's more what we're going to do here, the return thing. Yeah, I think. Let's see. So let's do something like let length be assigned the value of n. Oh, we're starting with n. Okay, we have to use something different. Let's just rename this. Let's just call it L, because it makes more sense that way, right? N digits, N for number, L for length, or D for digits. I don't know. We'll call it D for digits. They're just, yeah, everybody's happy that way. Let's even call it just digits. Why not? Yeah, okay, great. We're making good progress here. Let's continue. So length is going to be n dot toString dot length. Ugh. That's pretty boring, but we'll do that for now. And we'll say if length equals digits, then return n. We're just going to return that number. Let's see what happens if we do that. And so we are getting a 2-digit number here. We are getting a 1-digit number here, but is it the biggest? No, it's the smallest. Okay, well, that's no good. So I guess, you know, if we need the biggest one way we could do it is, let's say if length is digits plus 1, you know, if it's 1 bigger than that. And what happens then? Well, so now we have like the smallest 3-digit number here, and we have the smallest 2-digit number here, but notice this is just like one number greater than the 9 here. The 100 is just one number greater than the 99 here. So can I just return n minus 1? Will that work better? Yeah. Okay, so that's working for this one. It's working for this one. Is it going to work for all of them? Can we pass all the hidden tests this way? Oh, wow. Okay, I have to say I'm a little surprised by that. Yeah, okay, I was kind of expecting that to time out, but all right, that's fine. What if we did this? I'm just curious. If we said digits was 9, I'm curious about what it would return, if anything, at this point. I have a feeling this would time out. Yes, okay, execution time limit exceeded. So that's, if I had to take a guess, that's probably why they stopped it at 7, just so that anyone could just use this solution and, you know, not have a timeout or anything like that. But keep in mind, we're pretty close. So would it work for 8 digits? I wonder. Let's try this. Very suspenseful. No, okay, so yeah, that's like right at the borderline here. Okay, and geez, there's only 3 tests. I wonder if it even does do 7 as one of them. Like, is that the hidden test? Yeah, it could be. It works anyway. Okay, cool. But take a look. Like, we're maybe noticing a pattern about all these numbers. There's really only one digit we're using. We've got 9 here. We've got 9, 9, 9, 9 here. We've got a single 9 here. Okay, so basically the idea is, yeah, we could do it this way. This is totally fine. It passed all the tests. But really, if our numbers were any bigger, you can pretty much forget about it, pal. So, what are we going to do for this instead? Well, if it's just a bunch of 9s, then we could just do something like let number be assigned the value of 0. Should we start with that? Yeah, 0. And then for let I be assigned the value of 0, I is less than digits, I plus plus. Basically, we're just going to put another 9 on there. So, okay, there's a few ways we could do this. So one way we could do it would be to do it string-like. So we could just say number is concatenated with 9. And then at the end, we're going to say, well, return number. And we'll see what happens with that. We just get a bit of space in there. What? Oh, yeah, okay, that's... Forgot to change the value of that. Okay, good. So it's not passing the... Well, okay, maybe it's not good, but it's what we were expecting. It's not passing the test because we're getting strings here. We need for this not to be a string. We got to do a parse int on this thing. We got to make it an integer, a whole number. There we go. So we do a parse int, and yeah, now it's good. That works. But I don't want to have to do a parse int. I'd rather do it without a parse int. So instead, here's what we're going to do. Let's remember to change this one this time. Great. So we'll make this 0 to begin with. And if we want to change the value, we'll say, so number is going to be 10 times what it was. 10 times whatever number was before, plus 9. Okay, so if it was a 0 to begin with, well, 10 times 0, still 0, we add a 9 to it. In fact, hey, let's keep track of this. So what would be a cool color to use? Maybe like a nice brown or something like that. Yeah, that looks good. Okay, so we start with, okay, maybe I'll just say number, and that's terrible, isn't it? Okay, sorry about that. God, now we have to look at that. Anyway, okay, so I will go over here. Okay, so we've got number, we've got I. So number starts as 0. And then for an I value of 0, I guess, wait a sec. Well, okay, well, let's just say that's the number before, I guess, before we do the stuff in here. So basically, we've got a 0, and then number is going to be 10 times what it was. So 10 times 0, still 0. We add 9 to it. There we go, 9. And then I plus plus, I is going to be a 1 after that. Okay, so then we run this again. We say 10 times the number. Well, what's 10 times 9? It's 90. 90. We add 9 to that. Now we've got 99. Okay, cool. And then I goes up to 2. We'll keep this going until we get to digits. Basically, the next one is going to be 99 times 10, which is 990. And then we're going to add 9 to it, so 999. And that's going to be 3. And it's going to keep going until basically the value of I becomes digits. So if digits was 3, it would stop here. And it'd say, okay, you've got your number, return that. And because it's already an integer, we can just say return number. We don't need to, change it in any other way there. So, okay, not bad. That's a little better. Good. So, I like that better than the other one. I mean, just like in the previous challenge, if we can avoid, if we're given a number and we want to return a number, there's not much sense in turning it into a string if we don't have to, like, if you can just keep it a number the whole way, that's probably better for memory. It's probably better for computation time. And it's... Okay, now this part is debatable. I would normally say it's more clear to the reader, but I have had people tell me that, something like a reduce is usually more clear than like this kind of stuff where we're actually working with the digits. So, up to you. If you come from like a math background, maybe this is more clear to you. Otherwise, maybe you'd prefer like a different strategy. But there's one more thing I want to do here. I mean, look, we just need nines. And I know I just basically said that if we don't have to convert to a number, we might as well not. But there is a pretty convenient way we can do this by converting to a string and then back to a number. And it's basically by just doing 9, like the string 9, dot repeat digits. That's it. So it's going to repeat this however many times we need it to. So if digits is 5, it's going to give us 5 of these 9s. If digits is 1, it's just going to give us 1 of these 9s. And then, of course, that's going to be a string. It's going to be a string consisting of the same character a bunch of times. And then we'll do a parse int. It's going to make it an integer. It's going to make it a whole number. Well, it did make it a whole number. That's why we're passing the test. Okay, cool. So that's, we got a variety of ways of doing this. I think, let's see. Is there any other way we could do it? Oh, yeah, totally. There's another way we could do it. So check it out. Let's make this 4. Now, basically the advantage to this last one is it feels very direct. We're basically just jumping right to the final value, which is kind of nice. So I want to do the same thing, but now I want to see if we can do that without converting to a string or anything else like that, just keeping it a number the whole time. So what we're going to do is we'll say, the way we used to do this is like a math.pow. We want a power of 10 to the power of digits. What's that going to give us? Well, basically, this is the 100. Next one will be the 10. And we just need to subtract 1 off that. So it's just 10 to the power of whatever this is. 10 to the power of 2, 10 to the power of 1. And then we're subtracting 1 off of that. So that's pretty nice and convenient. It can get even more convenient. We can just say 10 asterisk asterisk digits. So 10 to the power of digits. And that's even nicer. It looks even nicer, I should say. Now, someone did point out to me a while back, apparently this is not ideal in the sense that apparently according to like JSPerf, math.pow, I think, runs slightly faster than the double asterisk. But it didn't seem to me like it was super huge. It wasn't like it was like a 700% difference or something like that. It was like a single digit difference in terms of percentage, I'm pretty sure. You'd have to look it up. Don't take my word for it, I guess. But anyway, do take my word for all of this, I guess, all this stuff we've done so far. This is a nice variety of solutions, actually. I'm actually sort of surprised. I wasn't really expecting to do that many different ones for this. So great. It's a richer problem than I was expecting. That's awesome. So let's submit this. We'll finish up with it. Great. Nice job, everyone. Keep up the awesome work. Okay, cool. So